The secret to AI success isn't always using the biggest, most expensive models. Sometimes it's creating smaller, specialized models that know your business inside and out. OpenAI's chief product officer just revealed that fine tuning is the most underutilized technique in AI right now. And today, I'm going to show you exactly how to master it. If you're tired of generic AI responses that don't understand your brand, your customers, or your unique processes, then this video is for you. Today, we're diving deep into AI fine tuning, the technique that OpenAI uses internally, and the one that can transform your AI assistant from generic to a specialized expert that thinks and responds exactly like your best team members. In this video, we're going to build a complete fine-tuning system from scratch using real data, and by the end of the video, you'll have a custom AI model that understands your business better than any off-the-shelf solution ever could. Let's jump in.
Let's go ahead and get started with the um, initial bit of theory on why fine tuning. So, one thing that we always find to be helpful at Dreamlabs is when determining which approaches to be following, we study the gold standard of the gold standard. Arguably, right now, in the AI space, OpenAI is the most important AI company in the world. So when the chief product officer of OpenAI discusses how his internal product teams use AI, we listen and we study to see what they're actually doing at the cutting edge. And this is recently what the chief product officer, Kevin Weil, said. Frankly, one thing that I'm sort of surprised about our industry in general, is that there's not greater use of fine-tuning models. So specifically, when we're talking about fine-tuning a model, what we're talking about is leveraging an existing foundation model, for example, OpenAI's ChatGPT 4o Mini, and then training that foundation model off the shelf with our custom data set to be specialized in knowledge that only we can get it. In terms of the general use cases of AI, there are a number of different ways, obviously, to go about leveraging AI. One use case is just using AI off the shelf. So that's connecting via APIs directly to the foundation models from OpenAI, from Anthropic, from Google and their Gemini product, and getting raw responses based off of whatever prompt and system message that you send. The second use case is providing specific information and documentation in the form of some sort of RAG system or CAG system. So this is essentially creating a vector database to operate as the additional knowledge library that the LLM has access to. So this is the foundation model plus your custom set of library documents that the foundation model has the ability to access when needed. And the third primary method is what we're talking about today, is around fine tuning. So that's starting with foundation model, training it on your custom dataset, and then producing your own custom version of that model, which is trained on your data and can access that and accesses that by default. So in terms of the pros and cons generally of fine tuning as a technique, one of the benefits of fine tuning is that you can very easily create norms around existing patterns of tone and style. So for copywriting, this is really strong. And you can also very easily embed common question and answer sets. If that knowledge is already easily available with your organization, so that you don't constantly need to get it more context, but it has that context baked in. One of the downsides of fine tuning is that it can be difficult to update if you need to have an active data source that's constantly changing or being updated on a daily or weekly basis. Fine tuning is much more of a run a process once every couple weeks or so, and have that core foundation really solid. So a few other pros and cons, but for now, we'll leave it at that. And in terms of when to use a fine-tuned model in your business, a few different techniques, the few different use cases that come to mind just to get the wheels turning. But these are obviously by no means prescriptive. So, for example, in sales, one thing that you can do is fine-tune a model based off of all of your CRM's closed versus one notes, so that your model can start to really understand for your business specifically, in your use case specifically, what are the patterns of sales tactics and approaches that lead to success versus failure. With that complete, then you'd be able to access your fine-tuned model to be able to guide your sales reps in determining recommended best next steps to guide a lead through your pipeline and maximize your chances of closing it. From the perspective of marketing, one thing that you can do is fine tune a model based off of only your highest performing content. So, ads, creative, posts, anything that you know for sure is working well for your business in your existing marketing channels. And once that fine tuned model is in place, then anyone who's not a marketing expert would be able to tap that fine tuned model to dump in some brainstorm ideas and then receive as an output tailored and refined marketing content based off of what's working best for your company. From the perspective of customer support, a really core use case is being able to fine tune model on both all of your resolved support tickets as well as any internal policy docs, so that you can have a fine-tuned model being the new frontline support agent to be able to handle most lower level questions or user queries, be able to resolve tickets that have already established a strong pattern of what answer needs to be delivered in an empathetic and user-friendly tone. And from a product perspective, we often see that different companies have their own nuances and approaches to product documentation. So being able to fine tune a model based off of all of your company's existing product documentation can then generate a model that understands the nuances and the patterns of your product ops, so that your process of translating either user feedback or executive priorities into developer ready product documentation becomes as effortless as possible. Of course, that's just scratching the surface. There are a number of other use cases depending on how exactly you want to approach these, but the point of these examples is to see what's possible with this technique. And in any of these given use cases, how to best leverage AI with fine tuning is essentially following the pattern of moving away from tapping off the shelf foundation models with large, high level one shot prompts, and instead breaking down a task into smaller subcomponents or subtasks, and then creating a fine tuned model for each of those subtasks along the chain. And again, looking at the gold standard of the gold standard, this is essentially the framework of how OpenAI leverages AI within their product teams. So moving forward, how exactly do we go about this? With the fine-tuned system that we've created, this system is currently developed with Notion and Anytype. However, any other vector database would also work. So instead of Notion, if you want to use Airtable or even Studiobase, that would also work just fine. If it's helpful to have those examples, templates out the shelf, definitely let us know. We can see if we can create another version of the template with whatever tool that you use, if that might be helpful. In terms of the high level starting points of our system, up at the top, we have our list of AI agents that have already created or are creating to be able to plug these fine-tuned models into our agents. Ultimately, that's what we want to use them for. Here in the center, we have our number of docs, databases that are all related to each other and required for actually developing and running the system itself. And then finally, we have our fine-tuned automations. We have 5 end-to-end automations that power the system and description of each automation, which databases are related to, as well as a JSON file for that template. So we can go ahead and now jump in with the starting point of preparing our training files. So for this part of the process, the 3 things that we're going to do is begin by preparing our content. This means getting the actual files that we want to train. Then we'll translate that content into message and response pairs. So for each of these training documents, we will break that training document out into a series of prompt response pairs that can fit the required structure that the fine-tuning process requires. And then finally, we'll select a subset of that training data, these prompt and response pairs, to actually turn into a JSONL file that is sent to a fine-tuning job. Ultimately, this JSONL file is the starting point that we need to begin fine-tuning process. So this is the outcome that we're looking for right now. For the purpose of this demo, I'll take a look at a few of the AI agents that we're either working on or have already developed with Dreamlets across marketing, product, and sales. For now, we'll just focus on this marketing agent for LinkedIn copywriting. And to go about that training, we're using an Apify scraper to get the 100 most recent posts that I've made myself, or that Tomas has made on my LinkedIn profile. So here we dropped in the profile min and received as an output the 100 responses. Drop that CSV into Google Sheets, remove the other columns, so we have just our 100 most recent posts here. And this, as our starting point, is what we're using for training. So to go about that in practice, we'll first start by going into the training files database and see that CSV that we just took a look at is set here. So for this train file, we have Tomas's LinkedIn content, which is the 100 most recent post examples. The file is uploaded here, and there's a CSV. Here we've set up an automation to run where when the upload checkmarks is triggered, then we send a webhook to the corresponding automation. So let's go ahead and take a look here. That says train files. So if we test this workflow and get that triggered, what you can see is that in Anytype, we sent that Notion record into the workflow, downloaded that training file, extracted all 100 individual items from that CSV, and are now running a LLM chain. You can see outputs parsing 9, 10, where for each of these posts, we're creating a prompt to go with that pair. After these responses are created, we'll then loop over all of those 100 output responses and create the train data in the separate Notion database with those prompt and response pairs. Here, we're looping with a limit of 3 records per second, or 3 records at a time, because Notion API has a limitation of 3 records per second being created. If you're using a different tool like Airtable or Sudabase, then this probably would not be as necessary. We'll take a pause here and come back after this has already been finished. Right. So now all 100 items have finished the processing. And now if we go back into our system, we can see that that file was uploaded. And if we go into our training set, we can see that we now have a custom prompt for each of the posts. So we have our prompt and a response for all 100 records. Perfect. And all of these records are also tagged to the file that produced it. So the final thing that we need to do now is create the JSONL file above our training set. So if we go into fine tune jobs, we can create a new job. And call this Thomas Lane Dental. And to begin the process of creating that train file, first we need to choose the train file input that we want to use. In this case, we'll use the LinkedIn content adjusted. And for the system prompt, you are a code and AI HCB holder hosting on LinkedIn to share insights of how to build books. So this is going to be the system prompt that will guide all of the content that the training data sees. So with these two fields hit initially, then we can, over there, you can see that we have two automations set up, both tagged to the status field. The one that we're looking at here is when the status is sent to create JSONL file, then we send a webhook over to the corresponding automation. Let's go ahead and go to create JSONL file and test the workflow. So for this new fine-tuning job, go to create JSONL file. And then in the workflow, we can essentially see that what we do from that job is get the record for the ID. If there are multiple training files, then we'll split those out. In this case, there's just one training file. So then we get all of those 100 records in the training data database that we just created, send those into a code node where we actually create the JSONL file itself with the system prompt that we just wrote, the user prompt, as well as the output response. Each of those becomes its own object or JSON line in the output JSONL file. We're running Anytype right now on the self-hosted DigitalOcean server. So we're then able to host that JSONL file into DigitalOcean spaces. After that's uploaded, we then get the custom URL for that new hosted file and send that into the Notion database where that job was created. So now we can see that that fine-tuned file .jsonl is read here. So this is what we wanted to get as our output from the first part of our process. And now we'll go into the second part of our process where we are creating the fine-tuned model itself. And here what we're going to do is configure a few model parameters, begin the fine-tune job, and then ultimately monitor the fine-tune job progress until it's done. So this is pretty straightforward. Essentially, we'll just move the status to start fine-tuning job and watch the progress from there. So if we go over to create fine-tune mo, and then test the workflow. What we'll do here is define our epochs. So for now, let's just put it as 3. Define our foundation model. Let's go GPT-4o mini. And then start our fine-tuning job. So this fine-tuning job triggers the webhook to send this data over into Ada. As you can see, we've the status just got updated, so we are in progress. The stats also got updated again from started to fine-tuning. And essentially what this workflow does is start by creating the fine-tuning job, by downloading, getting the record from that webhook trigger, downloading the JSONL file, uploading that file into OpenAI, and then creating a fine-tuning job with that uploaded file. After the job gets created, we then update the status in Notion, as we saw, to keep an eye on it. But then ultimately, the core loop is here where we just wait for the fine-tuning to complete. Essentially, checking the fine-tune job for its status. If it's finished, we update the related records. If it's not, then essentially we just keep looping around and waiting. But in terms of getting the most visibility of this process as it's unfolding, you can go over into the OpenAI platform. If you go into the dashboard and select fine-tuning, what you can do is take a look at all of your fine-tuning jobs as they're unfolding. So for example, here, we now have this from active, validating our files in terms of its status. And you can see the message below. There are a number of different parameters that you can update, toggle up and down. For the purpose of this video right now, we're just going to talk about epochs, which is essentially the number of times that the LLM will review a given data set during the course of a fine-tune job. So in this case, we're sending it at a training set of 100 records, and by setting epochs to 3, we're running over that set of 100 records 3 times. There's some pros and cons of dialing that up or down, which we won't necessarily get into at the moment, but just know that 3 is the kind of standard starting point. And then if you want to get different results, you can dial that up or down and kind of fine-tune for your specific use case. So in general, the fine-tuning job process will take about 5 to 10 minutes. So we'll go ahead and pause again until the job is finishing up, and we'll take it from there. All right, so now we can see that the status has been updated to succeeded. So from our base model of GPT-4 Mini, we now have our new output model, our new fine-tuned model of the base model plus our organization name, plus the unique ID. And great. We can go more into the details of loss and accuracy, if that's helpful, but basically loss going down generally is a good thing, and then accuracy going up generally is also a good thing. So if you see both of those general trends, then that is positive. So now that our fine-tuned model is complete, we can run our evals. So the first thing we want to do is create some evaluations to make sure that essentially to test how accurate the fine-tuned model now is for our specific use case. Then we'll actually run those evals against our new fine-tuned model, and then finally review the results. In terms of where we're creating the evals from, one source is generating out this, pulling a random set of the training data itself to see how the fine-tuned model compares to that initial training set. And then the second bucket is creating custom evals, where we're generating brand new prompts based off of the training set data. We're then getting off-the-shelf foundation model responses, and then we'll be able to compare the two. So for the purpose of moving forward and seeing that, here we can see that the status is now done. Great. So if we go into the fine-tuned model itself, we have our new model here, the LinkedIn demo. We have our new model ID. Fantastic. So if you have evals already, then you can go ahead and put those in database. But if not, we can create some programmatically here by going into the create new evals workflow. Let's go and append it here, and go ahead and flash the workflow. So as usual, we will trigger that workflow with the checkbox. So when the checkbox is completed, then it'll send that webhook. And essentially what's happening in this workflow is we're from this initial webhook, we're then getting the training job where the JSONL file lives. We're downloading that file, converting it to string, breaking the string out into individual records. So array, in this case of 100 items. And then for getting the random prompts, we're just selecting 3 random prompt and output pairs from the trained data itself. And then in terms of creating custom evals, we're getting a selection of 5 random prompts to then be able to create new custom prompts from. In this case, we're getting 3. And then for each of those 3 new custom prompts, we're just sending that prompt directly into a foundation file to get a response, and then putting those 3 prompt and response pairings in the Eval database as well. So now if we go over to our model evals, we can see that we have 3 custom evals and 3 random prompts. For the random prompts, what we have is essentially with the system message, we have our user message, as well as our oh, I think there was a error here. Okay, there we go. We have our user message in terms of what is the prompt that generated that should generate the output, and then our system message. So what is the actual post that was made? And then for the custom evals, we have again that sample response, that sample prompt that was created, and then just the raw system message. So the raw response that's created from the foundation level directly. So now the last thing to do is actually generate responses from the fine-tuned model that we just created. So now let's go over to, I'm saving, run on new model. So we can create, generate a response here, for example. Where in this workflow, what we're essentially doing is getting that webhook request. Here we're preparing that and essentially send the system message and a prompt into the new fine-tuned model, and then stating a response. In that case, the response is here. And then let's do another test. Test workflow. Let's do like here. So it's also running. Great. So now we have a couple of evals, and obviously once you actually consider the live version of the webhook, it gets check all the way down. But as an example, we can see that for the message of discussing evolving with the digital marketing and the necessity for agents used to adapt new tools, blah, blah, blah. With this response, with this prompt, if we were to send this prompt into just the off-the-shelf LLM, then we get something back that's like the vibrant world of blah 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 changes daily content. So pretty high level, a bunch of paragraphs and a lot of content. But if we send the same prompt to our fine-tuned model, then this is the moment to adapt or die. Again. This is great. So there's definitely much more in my style, where there's an initial like quote or hook or something at the top. It's kind of one line at a time, talking about agencies step by step. Yeah, this is great. So in terms of rating, I would say, yep, good. And then let's go ahead and take a look here. So this is the sample test data itself, where the prompt is generate a LinkedIn post highlighting how V0 was both entirely versatile engine post, built input, or blah, 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 blah. So this is the post itself that it had made. And I'll take a look at if this one prompt was included in the train data, then sending this same prompt to the fine-tuned model gives you almost exactly what was in the training data. So this is a really good example of, especially for the use case of like customer support, how if in your training data you have a common user question and then a confirmed answer, then you can expect that if that same question comes in again, your fine-tuned model will give you the right answer. So then here rating, good, very good. Um, so that's an example of how you can then run evals to make sure that the fine-tuned model that you created is actually ready for you to work. And then finally, we can go ahead and say that this fine-tuned model that we just created for the LinkedIn demo, we can attach this to our copywriter so that within my copywriting agent, which we can export a separate video, this custom model is now active, it's trained, and it's ready to go.
And there you have it. Your complete fine tuning system is now live and ready to transform how you use AI in your business. We just walked through the entire process from preparing your training data and creating prompt response pairs to launching your fine tuning job and evaluating the results. The difference between AI responses and your custom fine tuned models is like night and day. While everyone else is stuck using one size fits all solutions, you now have an AI that speaks your language, understands your processes, and delivers results that are perfectly tailored to your business. If this video helped you level up your AI game, hit that like button and subscribe for more technical tutorials that actually move your business forward. Drop a comment below and let me know what you're planning to fine tune first. I read every single one and love seeing what you're building. Want the complete Notion template and automation files we used today? I've linked everything in the description below, including the JSON templates and step by step guides. Next week, we're building an AI agent that can analyze user feedback sessions and automatically extract actionable insights, pain points, and product opportunities from hours of customer interviews. If you've ever spent days manually reviewing feedback only to miss critical patterns, this one's going to be a game changer. Until then, keep building and learning, and I'll see you in the next one.